What is the square root of 9.01? You don't really know what that is. I sure don't. But you know what? I'm going to guess that, it's probably pretty close to about 9. So square root of 9, it's about 3, right? But what if you need a better approximation? Well, you could use differentials or you could use linear approximation. But which one is better? Which one should I do? To compare the difference, let's just go ahead and do both approaches and see which one gives us a better answer. So let's start off with linear approximation. Linear approximation basically says, let's take this graph of, let's say we have the square root of x near x equals 9. That's about right. So let's say here's 9. 9.01 is going to be really close, but I'm going to expand out a little bit for demonstration purposes. If we get a linear approximation here, well, we're going to be off by that little amount. That's basically what linear approximation is. So let's go ahead and see that by finding the equation of the tangent line. So I'm going to say y equals y naught plus m times x minus x naught. We'll find the equation of the tangent line. That's the linear approximation. So y naught is going to be just the point it goes through right here at 9. So square root of 9 is 3. Plus m. Oof, we don't know the derivative yet. M is the derivative, but we can calculate the derivative using the power rule. I'm going to say y is x to the 1/2. So y prime is going to be 1/2 x to the negative 1/2, or I'll write that as 1 over 2 root x. So if I plug in m here, then I'm just going to get, let's see, square root of 9 is 3, so 1 over 2 times 3, so 1 over 6. That's the derivative, which is the slope of the tangent line by definition. And then we have x minus x naught, well, we're looking near x equals 3. So this is the equation of the tangent line. So that's going to give us, if we plug in 9.01, we'll get that answer here, which will be pretty close, right? So let's plug that in, see what we get. We get 3 plus 1/6 times 9 minus 0, or 9 minus 9, or 9.01 minus 9, sorry, is 0.01. So that gives us 3.16 is 0.6666. Move over the decimal 2 places, so we get 0.00166666. Repeating. Okay, so that is the solution that we got using linear approximation. Now let's look at differentials to see what's going on here. Keep that 3.016666 just as a reference so we can remember what we got for the linear approximation answer. And now let's do it using differentials. So using differentials, we're basically going to say y equals the square root of x, or I'll write x to the 1/2. Take the derivative and say that means y prime, or dy dx, is equal to 1 over 2 root x. Same thing we did before, right? But this time I'm going to note that as long as dx is small, delta y over delta x will be about the same as dy over dx. Now, if you're not sure, what does that even mean? dy over dx basically means that if you take an infinitesimally small x and an infinitesimally small y, both of those are infinitesimally small. They don't really make sense separately, so that's why you always see them divided by each other. But they have to be infinitesimally small, basically almost 0. Whereas delta y and delta x are just assuming that delta x is sufficiently small. What that means, it depends. Just small. So as long as that's true, these two are about the same. So I'm just going to say this is about the same as some change in y over change in x. Well, since these are now numbers, I can just multiply by delta x and say delta y is equal to 1 over 2 root x delta x. This is differentials. So that tells me that the change in y from a given x, say we start at x equals 9 and we move over 0.01, the change in y will be approximately 1 over 2 root x, that's root 9 then, times delta x, which is 0.01. So that's 1 over 6 times 0.01, which you may have noticed that this was a number we found earlier. That's 0.00166666, repeating. And then notice that this is delta y. That's the change from the initial y value at 9. So that's how much it changes from 3. So that's why we're going to add 3 to that to get 3.00166666 repeating. So this is our solution using differentials. Now wait a second. That was our answer using linear approximation. They're the same. And they will always be the same because they're actually the same concept. They just are approached a little bit different, but they're always going to give you the same answer. So it doesn't matter. If someone says use linear approximation and you prefer differentials, I say go ahead. Now you got to be a little careful because if your teacher says use differentials, they might dock you points if you do it a different way, but you'll get the same answer and it just doesn't matter. If you like this video, be sure to like the video and subscribe to the channel. Also, be sure to check out some of these other videos that I have to help you understand that math really can be easy for anyone.